Okay, this tutorial is still looking in section 3.4 in the triangles unit, and this is the ambiguous case. And now we're looking at the ambiguous case where the given angle is an obtuse angle. Now on page 22, there's two situations to check in this, and it's much more easier to check an obtuse angle. All you have to do is check if there's one triangle or no triangles. And all you're checking to see is there will be no triangle if the opposite side is shorter than the adjacent side, because then they won't connect up and make a triangle, or equal to, in fact, because if it's equal to, you just get an angle, not a triangle. One triangle will be formed if you get the fact that the opposite side is larger than the adjacent side. So let's draw the triangle and do our check. So we know that this is a 180, or sorry, not 180, 105 degree triangle. So, and we know that it's over 90, so we'll squeeze her back a little bit like this. And we know that this is 105 degrees. And this is y. And then this given line here is 12. And this adjacent side, let's call this one x and this one z. So this is z and this is x, which is actually 9. And according to the obtuse check on page 122, if the opposite side is larger than the adjacent side, we have a triangle. So there should be one triangle formed in this case. So now that we know that there is one triangle, we can go ahead and solve it. If this was 9 and this was 12, obviously it wouldn't swing around and hit that, so it wouldn't work. So we know that it's there, so we'll use the law of sines again. So we know that 12 over the sine of 105 degrees is going to be equal to 9 over sine x. Now, obviously, you can't have more than one obtuse angle in a triangle. Okay, so that's good, so that you know that these are going to both be acute automatically. So when you do that second function sine to get the angle value, you know it's acute. So let's calculate sine x. It's sine 105 times 9, degrees times 9 divided by 12. Let me just check my field of view. Okay, so let's plug that into our calculator, making sure our calculator's in degrees. 105 sine times 9 divided by 12 gives us a decimal number, so take the inverse sine of that. Angle x then is going to be equal to 46.4 degrees. 46.4 degrees. So we know that angle x is that. We know what angle y is, so we can calculate now that angle z has to be equal to 180, because all the angles in a triangle equal to 180. Subtract 105, subtract our calculated angle of 46.4. So angle z, if you were doing it here, that's 75, subtract 46.4, 28.6 degrees. And then we just have side z to calculate. So 12 over sine 105 is equal to the same thing as saying z over sine 28.6. Z sine 105 equals 12 sine 28.6. Z equals 12 sine 28.6 sine 105. Z equals. So let's take our calculator out. Take the sine of the angle, 28.6 times 12, divided by 105 sine, gives us 5.9. And that would be our completed, solved, ambiguous case of for ambiguous cases using an obtuse triangle to start with. Okay, and that concludes 3.4. Our last section, 3.5, is just taking, or our second last section, pardon me, is just taking and just solving questions plainly, just using anything, cosine law, sine law, right triangles, or using the ambiguous case when we need to. And there's a helpful, really, really helpful chart on page 127. And I think what I'm going to do for our next one is I'm only going to do maybe one or so tutorial examples. But realistically, it's just generally follow that chart on page 127 to help you out when you're doing general solving and it's not given to you to say, it doesn't say use the law of sines or use the law of cosines. It just, you have to figure it out on your own. Okay, so we'll get into that next tutorial.